somewhat slow, and we'll go faster and faster. We're going to be talking about custom service applications in SharePoint 2010. Probably the most complex topic that you can cover in SharePoint 2010. In SharePoint 2007, that would have been custom field types, and there's some things that we have in relationship to the way that field types were built that will build service applications. Primarily that we're going to have multiple classes that we have to deal with, and we're going to have to inherit from multiple interfaces in order to accomplish a goal. But the chief thing that I want you to understand is that these are achievable if you need them. It's going to be important, though, that you understand when you need them and make sure that you're choosing to do this for the right purposes, all right? So I'm going to first talk a little bit about the history of N-tier computing, something that you probably already know. I won't spend much time there. I'll then talk about topologies and the idea about why we even have service applications. What is the purpose in putting these things together? Then I'll describe the SharePoint 2010 Service Application Framework. The Service Application Framework is a little bit odd in that it's overly complicated, unnecessarily, at least in my opinion, overly complicated. That is to say that the product team made it so possible for us to override and to plug in certain components that it becomes quite complex to build one of these. So I'll explain through the Service Application Framework in simple terms so that you can understand the details about how service applications work in SharePoint 2010. Talk a little bit about the history of computing with regard to centralization of an application tier, if you will, and then finally the specific elements of the Service Application Framework, the anatomy of a service application. Does that make sense? Okay. This is one of the few times in the last decade where I'm going to do a presentation, a technical presentation, no demo. Because while I could probably whip together a service application in 75 minutes, it would kill you to watch me do it. I'd literally be just like making classes and whipping in code and seeing, see this big chunk of code, it does this. See this big chunk of code, it does this. And so I decided consciously that it would be better to explain the details about how this all works together so that you can go, oh, I see that chart he drew in the air. I can understand that chart. And when you go to build one of these, you'll understand the terms and the way that things fit together well enough that you'll be able to really utilize the underlying classes to your advantage, right? You'll be able to build one of these because you understand the concepts, not because you've seen the code. That said, hopefully by the end of this week, I will take the service application that we built, very, very simplified version, hello world kind of service application that demonstrates most of the pieces that you would need, and we're going to put that up on mindsharp.com. So MindSharp, it's an education company, like your mind is sharp. Right, so mindsharp.com, click on free resources. Sometime by the end of this week, I'm going to give it to my IT guy this afternoon, and he's going to put it up there sometime later this week. Just scroll down till you find Todd section. The Todd section listed there, that'll be me. You'll find slide decks and code snippets from all the various talks that I do, and you can find this one there as well. So you'll not only get this deck, but you'll also get the code that goes with a little sample service application. Hopefully that'll be useful to you as well. All right, so first a little bit about the history of N-tier computing. If you've been under a rock for a long time, right, we started with single applications running on a box, and then we went to client server, and then eventually said, well, client server is great, but we really need to offload the business logic from the presentation tier. So we broke it into three logical tiers of computing. The presentation layer, which basically says, here's the UI, this is what I'm going to show to the business user, and in that tier we're going to get all of the logic out of there so that all that's in there is presentation, right? Then we're going to store our data back on the back end called the data tier, and we're going to keep that in a database or some kind of repository over there, right? And then we're going to have this middle tier, and in the middle tier will be all of our semantic business logic, all of the rules that govern how the presentation tier should or shouldn't do things. At least that was the theory behind how we would make this stuff happen. So Microsoft came out with the Windows NT Option Pack 4. Windows NT 4 Option Pack. And the Option Pack had Scribble and a whole bunch of things. And in there was MTS. It was at the same time when we also had, what's the messaging tool that MSMQ, whatever that stood for. The messaging technology that you could send stuff around with. So that came with the Option Pack. MTS, Microsoft Transaction Server, was a concept that, remember the spinning balls? Anybody remember the spinning balls? Yeah, I see some people. Okay, so MTS was a great concept because it established a middle tier for Microsoft's DNA framework back in the day. Eventually, it became known as Com Plus, and they basically fixed some of the stuff that wasn't so great, and they made it a true product. Okay, so MTS became Com Plus, and it kind of looked like this. You had a server sitting over on one side, and that was where your actual code was running, and your code would be hosted by that middle tier, and then when your other server needed to have access to it, you would use a proxy on the local client to talk to the Com Plus component up on the actual server, server 2. It would go and do its resources, and it would work to do whatever it needed to do. I'm doing it backwards, aren't I? Right, so from the consuming service, it would call into here, and then that proxy would talk to the COM component, and it would do the thing on the actual server, sending it back across the wire so that it looked to the actual application as if it was running locally. That same concept is basically, oh, that's a really small graphic. It was big before. I made it big. Somebody else shrunk it down. But this is basically the same thing that J2EE does. Right? So the concept has been around for a long time. If you remember, Corba had basically the same concept. That is, we're going to have a bunch of objects in some kind of application layer, and then the front end is going to call into that. It's going to go and do the stuff that it needs to do, whichever servers it needs to do those things on, and then bring back some kind of result back to the presentation layer. Okay, so the conceptual idea was that we would subdivide this into 3 different sets of servers that could be our workhorses, and the front end could be farmed. Now, everybody understands what a web farm is, right? A whole bunch of web front ends where if one goes down, the others take the slack, right? So that we've got some fault tolerance built in there. The idea was that the database layer got handled by SharePoint. SharePoint provides a mechanism by which I can have multiple database boxes that are farmed out, where each content database is relying on a specific single point of failure, right? But I can at least horizontally partition my data across multiple content databases so that I can have lots of databases on different boxes managing the data in one single SharePoint web application. So on a site collection by site collection basis, I can kind of assign which one of these databases is going to take care, which database server is going to take care of the needs of a given site collection. The middle tier, though, has been a problem. How do we scale out that middle tier? For SharePoint, we've had a history of really odd implementations for helping that app layer, the business logic layer, get scaled out. I'll talk about that momentarily. But the idea was that we would scale out 3 different tiers, right? And each one of them would be somewhat distributed, scalable, fault-tolerant, load-balanced. You can read the list, right? Basically all the big buzzwords that make our computing less fragile, right? So we want this middle tier to happen. However, what we learned in our MTS days was that sometimes it didn't work to actually scale that out because most of the time the presentation layer talked an equal number of times to the application layer. So the presentation layer and the application layer end up being roughly equivalent. So it's better to distribute my hardware such that I've got both a presentation and application together on each server. Then I can scale out both of those tiers simultaneously. So that's the actual topology that we ended up with. We found this was cheaper, took less boxes, right? Made the load balancing better because since I had more boxes in my overall tier, I had 3 boxes instead of 2. You know, if you compare that to the previous slide, I only had 2 boxes per tier. Now I've got 3 boxes in this one, right? So if one of them goes down, I still got 2 to handle the thing. And the layers were evenly distributed. So the app layer and the web front end layer were roughly equivalent. However, what happens when the app layer gets to be too big? Right? When the app layer starts to take over a server. This happened a lot back in the day. That's not mine. This happened a lot back in the day with reporting. Right? What would happen is that a request would come into a web front end to make a report, and that server would freeze and go off and basically do this report, and in would come additional web requests, and they would queue up just waiting for that server to become available. Right? And so we had a problem because the app layer was too large. SharePoint ran into this right away. Right, because we've got search indexing, right? Search querying. We've got jobs, like timer jobs that could run. So we ran into several things that were causing us a latency on our web front end tier. And so SharePoint had to solve this middle tier issue. So why use an application layer at all? Right? The problem we're trying to solve first is that our web front end can be overcapacitated, such that a single request could hold up a whole bunch of other requests that get load balanced to that box. So we want to offload the processing of something that's incredibly resource intensive so that it's isolated to a dedicated set of hardware. Okay, it can take forever over there, we don't care, as long as our web traffic can continue to respond in a responsive way, right? So we want to offload resource consumption. According to me, there's a second reason. The second reason would be to centralize state, right? So we can do some state management within the out-of-the-box SharePoint components, but what if I want to take and put one common set of very expensive to acquire data into memory in a SharePoint farm? How would you do that? Not easily, right? You're going to have to come up with some mechanism by which you're going to redirect every single request into a centralized resource. I'll explain how ASMX and WCF play a role in how this overall process works. But what I'm just saying is that we could use the Service Application Framework to create a single instance that everybody talks to. And that one single instance can be maintained as a single source of truth so that everybody else can talk to this one, and this one knows how it's supposed to respond. So some kind of centralized state, and then cross-platform support. The ability to set this up once on a set of servers and then make it available not just to this farm, but to other farms as well, right? So those are the three big reasons why the Service Application Framework, sorry, I jumped ahead. That's the three reasons why you might want to use an application layer, right? So that you can get these kinds of things. So why not just build a web service? Why not just go the traditional route and make an ASMX web service? After all, this gives me some mechanism by which I can centralize the business state off on an isolated set of boxes, right? I can go set up an IIS website over here, put some web services there, and then take my web service call off of my web front end, isolate it over here, have it run. It can be load balanced across multiple secondary web front ends, if you want to think of it that way. And so I could make my own application layer using just simply web services. However, they don't have custom management. How do you manage a set of web services? At the command line, right? Or in IIS. There isn't any kind of centralized way of managing the overall approach to this. Second way is externally, right? You have to externally load balance these. So you have to go get some kind of big appliance to make sure that they're load balanced. Or you have to write your own load balancing capabilities, or maybe take advantage of the load balancing that we find inside of IIS. The next one down is you have to make direct web method calls. So that means that each one of your applications needs to know exactly where this web service is running, or at least the load balanced URL where you can make those calls to. And that can be a challenge. And of course, we've got custom disaster recovery, because there's no built-in mechanism for backing up and restoring your web service data. And then finally, you get Boolean permission management. That is, either somebody has permission or they don't have permission via some mechanism through IIS. Right? You're either going to say, hey, this Active Directory group has permission to this web service, or it doesn't. That kind of thing. All right? Now, the Service Application Framework, then, is created in order to mitigate some of those ASMX WCF service sort of issues. The first is that it's hosted so that we can get an application layer that, similar to the other application layers that I described, like MTS. I always call this COM plus minus. So you know what COM plus is. That's the original tool that kind of went away when .NET Framework got released in the year 2000. COM plus went away, and instead we get enterprise services in the .NET Framework, which nobody uses. The reason that nobody uses enterprise services is because it looks a lot like the previous slide. You know, there's custom management. You have to write all the stuff yourself. It's basically just facilitates an application layer, but it doesn't provide any sort of surrounding management capability around that layer, right? So the idea here is that the Service Application Framework is going to provide a shared set of services in an application layer consumed by all of my internal resources and potentially even external resources if I make that available, and it's extensible. So I can take advantage of this framework to host any kind of middle tier. It's a J2EE competitor, if you want to think of it that way, okay? Now, Service Application Frameworks not only provide the mechanism to set up an application layer, but they also provide a mechanism to provision that application layer We can either do that via PowerShell, or we can do that through the farm configuration wizard, or even via central administration by simply clicking on a menu and saying new. And they'll go ahead and push out all the bits to wherever they need to go, right? And then when you say, I don't want that anymore, they'll retract all those bits. So it'll automatically make that happen. It'll automatically generate an application pool should you need one. It'll automatically configure the configuration database and build out content databases if that's what you need as well. You can create optional management pages to create new service applications, to manage them and or to set their properties. These are claims aware because SharePoint is claims aware. So if you can get to the SharePoint web application, you can kind of think of a service application and a web application as being kind of similar things. A web application having many of the same properties that a service application has. Okay? So they're claims aware. This is really cool. If you ask SharePoint or tell SharePoint about your database, then when somebody backs up SharePoint's databases, they can optionally also back up your service application databases, such that when the restore comes along, your databases come back right at the same level that all the SharePoint databases came back. That's how all of the SharePoint service applications work for backup and restore, right? So since they can do it, so can our service applications. And of course, you get to tap into their load balancer. They have a software load balancer. It's a round robin that allows us to say, hey, I've got 6 servers. Or sorry, let me say the central administrator gets to say, this service application is going to run on server 1 and server 2. And so the load balancing of those 2 servers is going to happen because we can just call into their load balancer. Should we not like that, we can plug it out with our own and say, hey, I got a better way of balancing out these servers that the farm administrator is going to choose. But we get load balancing just built into this framework. And then finally, custom permissions are built into central administration. So if I basically tap into the interface for building out custom permissions, I can say anybody assigned this thing in my service application is allowed to do these things, right? And then that whole infrastructure for surfacing those custom permissions in central administration is made available to the farm administrator. Pretty cool. So a little bit about SharePoint history. I won't go far on this, but in SharePoint, I'll just explain why SharePoint needed one of these, right? First, we had SharePoint 2003, and we had what was called shared services portals. If you remember back in 2003, every time you would create a new, what we call web application, it would make basically a new portal. You only could make a finite number of portals, 20 per farm. So you either had to say, I'm going to make a portal, one of my 20 portals, and I'm going to say I have services running on that. And then, so like search or like user profiles and those kinds of things, my sites, those were all in one portal. And then you would say, now this portal over here, the second portal is going to use the services from the first one. And you could go and you could say each portal could consume the one centralized portal that you created for those custom services. However, the problem was that you either had to create one shared service portal that everybody consumed, or you had to make separate shared services, or separate non-shared services, I guess, in every single portal that you built. Right? There was no flexibility for saying, well, this one's going to use these pieces or whatever, right? It was a one-to-one relationship between the new portal that you were creating and the existing shared services portal, right? Compare that to the previous release, SharePoint 2007, where they came out with SSPs, shared services providers. Hey, it's a step in the right direction, right? The concept there was that we could go ahead and get search, user profiles, audiences. You can see the list there, right? We could get them all configured into a collection of services that didn't require a separate web application. However, whatever that grouping was, we had to still do the, hey, this web application is going to use this group of them. If I needed a separate kind of a group of them, I had to go make a whole new SSP and recrawl and reread all of how can I say it, user profiles and stuff. So reestablish all of the data that went into each of those shared services. Well, that's not very efficient. It'd be nice if each shared service was independent, and then I could say this web application uses this one and that one, right? So that I could sort of choose the collection of services that I was going to associate with my web application. So guess what they did in SharePoint 2010? Version 3, they finally got it right. They said, let's make an application layer that's pluggable, that we can make available so that anybody can build out an application layer, com plus minus, right? The kind of thing that we have wanted to have all along, such that any given web application can be related independently to each of the service applications that gets created. And then the service applications will be load balanced across the set of servers that the central administrator says that they should be. That's the concept there, all right? It's built on top of WCF and surfaced in central administration. so that we've got this custom administrative framework that people can create applications that can be load balanced onto a set of hardware, one or more servers that the central administrator chooses, right? Services on server, you've seen that screen, services on server. You get to pick which servers this service is going to run on. Each time you say a service is running on a server, they run out and install some bits, right? And then those bits are on that server and ready to be configured so that you can say, hey, I want a new instance on that server, right? And then that instance will be running such that each one of the servers where a service is running on that server is available in the pool so that I can load balance across all of those servers that are running that service. That's the idea. And then, of course, it's extensible, hence what we're discussing today. So, a few examples that come out of SharePoint 2010. I mentioned offload resource consumption, centralized state, and making it available across farm, right, cross-platform. So you can think of like resource consumption. Excel services, very, very resource intense. Lots and lots of calculations. You want that running on your web front end? Probably not. You could probably throw access services and BCS and all kinds of things into this same category, right, where there's a heavy amount of resources being consumed in order to deliver the request that was made. Performance point, lots of reporting, right? That goes back to that search, one of the original reasons that they needed a centralized application tier. Centralized state, web analytics. Don't you want to have one place where you go and you get all of the analytics for your whole farm? Right? That's a service application that's established in one place, and then every time I want to talk to that database, I go to the one place. Maybe I load balance across so I get my reporting CPU resources, but it's all coming back to a one common set of data. Managed metadata is another example of centralized resource. We have one single source of truth for what is the valid list of values that I'm going to have in a drop-down list, or the keywords that I'm going to use for my users to what do you call that? Mark up their data so that people can find it. And then finally, cross-platform. Managed metadata is another one. I set up one farm with a managed metadata service, and I tell all my other farms, please use this service application. Right? Please use the one common managed metadata. Don't replicate that in every single farm. Search is another example of federated indexing, right? The idea that it's been indexed already, so just go use their index instead of recreating it. There's a couple of custom ones that I mentioned here, just so you get an idea about what I'm talking about. We could build a resume crunching service application, such that anytime anybody uploaded a resume via the web front end, we don't do the crunching right there on the web front end. Instead, we go ahead and send that over to the service application. And we can do any kind of interrogation we want and any kind of analytics that we want, because the CPU and the resources associated with consuming that resume for indexing it and so forth and putting it into our repository of resumes won't consume our web front end. We can still be responsive to web traffic. Second one, who's online? This is the one I'm trying to build for my book. Here's the idea. Wouldn't it be nice to have one centralized state, very volatile state, of who's recently logged in? Who logged in the last 3 minutes? Or sorry, who visited a page in the last 3 minutes? So I can tell who's been online in the last 3 minutes. Well, that means that every single page request that comes in has to go through some centralized resource. Now, I could call a WCF service to make this happen, right? But then who's going to manage it? What if we want to change it to 4 minutes? Where's that setting? In some web config file in some server somewhere? Whereas I could surface it on a properties page, right? What if I wanted to keep track of everybody who had viewed any page anywhere in my farm in some database? Well, I want to back that up and restore it. I don't want to have to create something new. SharePoint will do that for me. So if I use the service application framework and I have my central farm administrators just go and manage this through their normal process of managing service applications, they'll already feel comfortable and familiar with creating a new one of these on the farm and setting up, managing it, and setting up its properties, and then monitoring it and running jobs against it. I can run actually timer jobs just against my service application to do things on my custom database, those kinds of things. Cross-platform, what if I set up one common my company's sandbox solution store? Hey, that's really needed, isn't it? Anybody find it frustrating that sandbox solutions don't have a way for you to say, these are all the ones that we built, so these are the ones we want our users to have access to? Guess what you end up doing? Putting it in a document library and then sending out an email to group staff. Hey, everybody, you can find our sandbox solutions over here. Download them to your C drive and then upload them to your site collection. Wouldn't it be great if we had a service application that would just surface that through some kind of a site collection administrative page? Yeah, some centralized way of saying, this is all of our sandbox solutions. across our enterprise so every farm can consume that one common resource. Follow what I'm saying? Okay, so there's lots and lots of good examples of where you might use this, but be careful, because if an SMX web service or a WCF service would suffice, and there's not a tremendous amount of management around what you're trying to do, then this might be overkill. Right? This is going to take a tremendous amount of effort to get this in place, and you don't want to put all of those resources in place only to find out that, you could have done it in an afternoon with a typical WCF service. So, this is the steps. This is the anatomy now. Here's what you have to do in order to build a service application. The first thing you need to do is create the service that you want to surface. Right? Now, that might already exist. Let's say that you already have a commercial software application or even a proprietary software application, and it already has services, and you just say, I want to surface these. Step one, check, right? It's done. You don't have to do anything else. But if you don't have the service already existing, well, then you've got a couple of things you need to consider. First of all, you're going to have to create some kind of WCF service. Right? You're going to need an SVC file that's going to say, I have the capability of surfacing this guy. Don't miss the replaceable parameters in the service host factories if you're going to auto-generate your endpoints. I'll talk about that a little bit later in the talk. But auto-generated MEX endpoints are really nice if you service your WCF service application or your WCF service within the ISAPI _VT_bin folder within a SharePoint web application, because then you don't have to do any web config modifications at all. You don't have to configure any kind of config file, and yet you can still have an endpoint to your WCF surface. So just be aware that if you create an SVC file, inside of it you're referring to your assembly and SharePoint's assembly for auto-generating MEX endpoints, and you can take advantage of the replaceable parameters to do that. You're also going to need some kind of a contract, probably a behavioral contract for sure, and maybe a data contract inside of your WCF service. I'm not telling you anything you don't already know, right? This is just a WCF service. You're going to go build one of these. There are two SharePoint-specific things, though. If you're going to have the Service Application Framework auto-deploy your WCF service for you, you're going to need to specify a config file in the SharePoint root for web services and for web client. Web services is the config file that has the WCF endpoints for your WCF service. For the server-side functionality, I'm going to talk about server-side and client-side, okay? The server-side functionality looks in that first folder, web services, and the client-side functionality looks at the web client folder for a client.config file. So you got web.config in the server, and you've got client.config in the web client folder. And then, of course, you must deploy the DLL to the GAC. Why? Because we're not in an HTTP context. There is no specific bin where we can put our DLL that it'll always be running. This is kind of like the timer job framework, right? It's running in limbo out here. So it needs to have access to that DLL even if there's not an HTTP context that they can rely upon. If it's going to the GAC, and if I'm modifying central administration, can I do this in a sandbox solution? Absolutely not. No possible way. Okay, so we're going to be in a farm solution. If you're in Office 365, this isn't happening. Right? You can't be in some hosted environment in order to create your own service applications. I would hope that that seems obvious, but maybe it isn't. Second thing that you have to do is you have to go ahead and create the infrastructure for your service application. The name service application is a little bit challenging because it's comprised of many different moving parts. I'm going to identify 5 of those moving parts. This is really the core of this talk, is to understand these 5 moving parts and what they do, what their role is in the overall function of delivering a service application. So let me just repeat. First, you need to have a service application. First, you have to have some kind of service to surface. Right? You have to have some kind of functionality. It is theoretically possible to take the functionality that you have in this service application WCF service and instead embed it into one of these classes. The service application class can actually just be your service. So if you don't want to create a WCF component, you just want to embed your functionality directly within your service application, that's possible. In fact, the CKS Dev has an example project of exactly doing just that. A non-WCF service application that has all of the functionality buried in the service application class. Okay, more about the classes. I'm going to explain each one of these classes in depth, okay? But first, let me go back, just say it again. If you don't have a service to surface, then these 5 classes are kind of irrelevant. Right? You have to, what are you going to have? Your resume crunching service has to exist, right? Your Who's Online service has to exist. So you first have to create the service. Once you've got that going, then you can start to build out your actual service application. There's a couple of other things that you might optionally want to do after your service application is functioning. Okay, so I'll come back and talk about those 5 classes momentarily, but there's other things that you might want to do as well. One of the things that you might want to do as a dev is create a post-deployment automation of what the central farm administrator would normally do. I usually do this with a PowerShell script. So in other words, you don't want to bake into your actual implementation of the service application the things that the central administrator would be responsible for doing, like turning the service on a specific server or creating an actual new service application inside of central administration. Those are tasks that or adding it to an application proxy group. Those 3 tasks you'll want to do inside of oh, they're right there. How about that? I didn't realize they were there. So you're going to want to provision a service instance, provision a service application, provision the service application proxy, and add to the default proxy group in your PowerShell script. You'll see an example of that in the service application that will be on the mindsharp.com site. But the idea here is that as a dev, every time you deploy, do you want to have it all ripped out, redeploy, and then you have to go visit a whole bunch of central administration screens, clicking through to do what the central administrator would normally do? Probably not. Right? So I highly recommend that you create some kind of post-deployment PowerShell script that would do those things for you. Secondarily, you might decide that you're going to create a new service application on behalf of the central administrator via any one of these 5 different mechanisms. Right? So you might say, whenever we deploy this, we're going to use a feature receiver to automatically create one. Maybe we'll even hide it from the central administrator. So if you deploy my WSP, then you get the service. If you retract it, it goes away. So maybe I use a feature receiver to create a new service application. However, there's a bunch of other ways you can do it. Of course, you're in central administration, you can go, if you guys all been to the service application management screen, you click on new and you see the list there, right? So when you click on one of those, you get a new page. Where'd that page come from? Well, if you don't have a new page, then they can't use that capability, right? So we're going to need a new.aspx or something like that for them to actually create a new service application. Usually you're going to ask them for what application pool, an existing one or a new one, and then whatever kind of characteristics that you need to know about for your service application. You might just say, skip the new screen, we won't even have it on that menu. They're going to have to go to PowerShell, run a PowerShell commandlet in order to make this happen. It's optional, you don't have to do one of those, but you're going to need to pick at least one of these ways, right? You're going to have to wire it up so that when they run the farm configuration wizard, it prompts them and says, hey, here's service application. Do you want to include it in the web applications that you're generating or in this application proxy groups that you're making or not? And then the last one is just making a web application create page. So when the web application create happens, somebody goes, I want a new web application. At the bottom, there's the application proxy groups, right? Or they can choose which service applications they want. Do you want yours to show up there or not? That's an interface that you have to implement in order to make it show up there. So there's 5 different ways of saying, I'm going to enable or empower my business user, in this case the farm administrator, to be self-sufficient. So they don't have to contact me to go make one of these things. They can click through an interface or go to PowerShell or whatever they want in order to make a new service application. Both of these are optional. You don't have to do either of them, right? But the second one, you have to do one of them. You have to somehow create a new service application or provide a mechanism by which the central administrator can, okay? Other optional things is, there's the new.aspx again. So there's 3 pages that you can do in central administration. I gave you the bar of central administration service application management, okay? So new, that's the one I was talking about. You've also got manage and properties. There's like 2 icons between each one of them. Those are pages that you get to choose whether you have or not. You don't have to have a new page, right? You could just create a new one imperatively. But once you've created one, whether it's via a new page or some other mechanism, you get to optionally decide whether there's something about that service application for them to manage. That's the manage page. Like, make sure you're putting management stuff on the management page. Don't look at the examples Microsoft gave you. They're really crappy. Their management pages have all kinds of properties, and their property pages have all kinds of management. And you're like, you called it manage and you called it properties. What'd you make 2 pages for if they're the same? Right? So make sure you're putting your managed stuff like, for instance, maybe you want to have some mechanism in the Who's Online to say, hey, it's been a year. We want to truncate the size of the database to only the last 3 months. Right? So you create a manage page that would say, crunch database or reduce it to 90 days or something, and actually run a function to manage the database. Whereas the properties might be, we want to keep track of everybody who's been online for the last 3 minutes or 30 minutes. or whatever your parameter is, right? So we as devs have to decide, okay, what goes on the properties page and what goes on the manage page. Just don't look at Microsoft's examples because they're really horrible. Publish and connect. So here's the idea. If you want the ability for external farms to be able to consume your service application, then you're going to have to wire up a simple interface inside of your code. It's an optional thing. You don't have to allow it, right? But you have to wire up an interface that responds, that will give out your endpoint. That's it. It's a very simple interface that basically says, if they wire this up to publish so that somebody else can connect to me, I can give out my endpoint so that those external farms can come and find my service. You have to identify, or these are freebies actually. The identification of administrators is built in. So you don't have to do anything necessarily to make that functionality available, but your service application can have an independent set of administrators. That's just built into the service application framework. Here's my service application, here's my administrators. And then finally, not finally, there's one more slide. These are all optional things. You don't have to do any of these things. What I find really frustrating is, if you go look at examples in the SDK, or anybody who's ever talked about this anywhere, they all mash these together as if you have to do all of these things, or you have to do some of these things. Everything I'm talking about here is optional. You don't have to have custom permissions, right? You don't have to have any permissions at all. You can say, hey, anybody who uses my service is fine. I don't have any kind of restrictions, right? Or you can make it as refined as you want. Hey, you must have this custom permission that I created. Again, inherit from an interface, right? Override some methods. Say, these are my permissions. Establish them such that whenever you call your code, you go check whatever kind of state you stored to say, hey, who's in that group? Oh, is this person who's doing it in that group? If they are, go ahead and continue. If they're not, then send back an access denied, right? So you get to establish where you want these custom permissions or not. Same thing is true of these other optional things. If you want the Service Application Framework to provision your database, that's fine. You just have to go implement a couple of methods and say, here's what my database should look like. Here's the schema I want you to use. Go make a database for me. Usually has a GUID in its name, right? And then later, when it's time to unprovision, you have to go and make sure that the code is there to tear down your database. They'll do the creation of the database and the tear down of the database for you, right? They'll manage the database for you. They'll back up and restore the database for you, but you have to establish what it looks like. What does your database look like? Okay? You can also create timer jobs. You can make your own timer jobs that will look for your particular, the servers that are assigned to your service application. These are optional, but could be really beneficial, right? Maybe I want to create a timer job that runs once a week to go out and get rid of the excess rows in my Who's Online database. Just every week go out and do some maintenance on the database or something like that. And then, of course, you can create a custom load balancer, which I've already discussed. This little picture should help to begin to understand the 5 classes that I want you to leave here understanding. And you know what? I don't know what time, how am I doing for time? 35 minutes, perfect. Okay, so first thing you need to understand is a service, top right-hand corner. What is a service? How many people did a custom field type, just so I can kind of get an idea? Custom field types, spattering, 10%. Custom field type, the first thing that you do is you say, there's a kind of field in SharePoint, I want to be like that one. So you inherit from one of the existing fields. All that class, all that custom field type class is establishing that you have one. All the service class does is it says, I have a service. Its name is this. It has some limited set of very basic properties, but I have a service, right? You get one of those per farm. So your installation of your service in your feature receiver should say, go make one of these for the farm, because they just installed the thing, so make sure that service shows up as something that you can use. Okay? The second one there is service instance. This is what I call the on-off switch, right? You go to services on server, and you find a server, and you say, it's on this server. It's off on this server. So if you got multiple servers in your farm, any server that's got SharePoint bits and is a member server of that farm, you can go and you can find that server and say, turn the service on this server. What does that do? It makes it possible for you to say new in the Service Application Framework. So it makes it possible for that server to host a service instance. Okay? If you don't have that turned on, then they can't. So what's in there? Well, it's a very simple class where you override some methods and you make it possible for the service to, well, you know what? I'm going to talk about these in depth. It's an on-off switch. Okay? I've got slides that explain each one of these. Then a service application, that's when you actually say new on the service management screen, and it shows up as one of the services that you can manage and set properties of, right? And set the administrators and go and do custom permissions and all of those kinds of things. So the service application, that that will show up as a single line there. Automatically, you'll get a service application proxy. That's on the left-hand side. It just says application proxy right now. But the service application proxy is a class that we're going to use to consume this on the client. You have a default service application proxy for each service application. The service proxy, then, is just like the service. You get one of those per farm. So where are you going to establish that you have a service proxy? In the feature receiver, when you go and you create, or when you deploy your WSP. That's you as a dev, that's your responsibility to tell the farm you have a service and you have a service proxy. All those classes do is effectively say, I have a service and I have a client-side consumption of that service, right? Then service instance is the on-off switch. Service application is the actual thing that does the work, that calls the WCF service or actually executes the code. Then on the left-hand side, is that left-hand? Yeah. The left-hand side, you've got application proxy. And the service application proxy is the actual mechanism by which the client is going to talk to the service application proxy based on which service application proxy group it tells it to talk to. So this is like an object that's already there that you're just going to borrow. Remember MTS? Remember that whole COM plus discussion? This is the object. This is the spinning ball. This is the one that's sitting there, the just-in-time activation kind of deal. Right? So you're going to say, I want to use that object that you already made, and I want to make calls through the service application proxy to the service application. The service application is running on a set of servers that are load balanced. Which one am I going to use? Well, the load balancer is going to determine which service application you're going to go to. Go to this service application, and that service application is going to then talk to the actual service, or be the service, one of those two things. So is this starting to make a little bit of sense? I'm going to repeat this several times, but I'm going to just say it one more time because this slide is sort of pivotal in your understanding of the overall consumption of how the service application framework works. So let me start on the left-hand side this time. I have a client. It needs to talk to the WCF service over here. How's it going to get to this WCF service over here? Well, it's going to say, hey, SharePoint, give me your service context. Hey, service context, what are the collection of service application proxies I have available to me? It's going to say, here's a collection. You say, I want this one. Right? So that's the application proxy. It points there to the middle layer. The application proxy says, hey, I've got a service application on these 3 servers. Hey, load balancer, go find which one of those service applications that I should be calling next, and it makes the call to the service application on the specific server. That service application on a specific server then makes a call to the WCF service that I originally wanted to talk to, right? And then it gets chained all the way back through this whole process, back to the client. Now, so that means the only 3 things I didn't talk about is service. I got to do it this way. Service, proxy, and service instance. Service and service proxy, those are basically just saying, I established that I have one of these. Right? So once you've established them, you don't have to worry about them. You created them when the solution got deployed. And then the service instance is whether it's turned on or not on this server. So those 3 classes are fairly simple. Right? The other classes are basically about establishing how I'm going to make my call through that whole chain of things. So this is the collective of things that has to be put in place in order to make this thing work. So core components. First thing I want you to do is you create your service. Whatever your WCF service is, get it out there. Right? I'm going to talk about that momentarily. Then you're going to make your service application. You create a new Visual Studio project, and you're going to add 5 classes to it. All of those classes will be public. Right? Because they have to be available to the service application framework to manipulate. Secondly, they're going to inherit from at least a base class and maybe also an interface. So get used to the fact that it's probably going to be inheriting from a class and implementing an interface. That's at least 2 things. And sometimes there's a second interface that you have to implement if you want to do some of the optional stuff. Okay, so base class and at least one interface, maybe a second interface. Each time you add an interface, there's a couple more methods to override. Maybe a couple of properties to set. All right? For serialization purposes, you need to decorate each one of these classes with a GUID. I highly recommend that you make it a lowercase GUID, because there are places in SharePoint where uppercase letters in a GUID fail to resolve. So make sure that your decorative GUID on your public-facing classes are lowercase. Highlight the whole thing and hit Control-U. I call that undercasing. Instead of uppercasing, we undercase them, right? Control-U, undercases, Control-Shift-U, uppercases them. Anyway, so you're going to make a lowercase GUID on top of your class. Also include a parameterless default constructor. So I make 5 classes, make them all public, decorate them, and make a default constructor in them. Yeah? Each one of them is going to end with a suffix that looks like, let me go see if I can go, how far do I have to go back to get them? I said it right here, but I didn't make it very clear. That's the suffixes of your classes. So I would say I've got the Todd service, which has the Todd service instance, which has the Todd service application, blah, blah, blah. Right? So my service plus these suffixes. That makes it very easy for me to come in and read your code. Because otherwise I'll be like, what does this class do? And I'll have to go figure out what the base class is and figure out what's going on. So if you use those suffixes, it really helps. All right. So now, one more. Nope, too far. There it is. So the fourth thing you're going to do is you're going to override type name. Yeah, type name. Man, oh man. You'd think that they would actually use description, because there's a description inside of every one of these classes. But the description is never surfaced anywhere in any interface. So it's either name or description or one of those. I've implemented it in every one of them and looked at all the interfaces and I can't find it. However, the type name, which of course is by default the name of the class, right? The namespace and class name is what they surface in the interface. So if you don't override type name, you're going to get a whole bunch of things that the central administrator is going to go, holy cow, what did you put in my farm? Right? Because it's big, long namespace dot class name. So you're going to override the type name so that there's a nice display name that shows up in central administration when the central administrator goes to work with your classes. Then you're going to, what am I saying here? Then all of these, the DLL has to go on every single server, right? So it has to be in the GAC of every single server. So put it into a WSP, deploy it all out. You should never be touching the file system of any part of your farm unless it's in a WSP cab, right? So make sure that this is all stuck in there so that they're available on every single server. It's just like everything in SharePoint, right? All bits are on every server so that if they go services on server, turn it on there, it'll work. Turn it on over here, it'll work. So wherever it gets deployed everywhere. So the first one. This one just says, I have a service. That's all it is, right? I have a service. It inherits from SPIAS web service. Or if you're going to implement your own WCF stuff, you can drop off the IIS web in all of these classes. And you can just say SP service. You don't have to say SPIAS web service. You can just drop off the IIS web and you'll have a non-WCF specific. The problem with non-WCF specific ones are that they can't be managed by the central administrator, which is one of the big powerful sort of selling points of this. So having a non-WCF based one means that they can't auto-deploy stuff everywhere you go. So they can't use services on server as well. You lose something. You get basically a single server implementation rather than being able to farm it out across multiple server endpoints. Like for instance, I can't easily surface that to other farms because it's not WCF. It's just sort of baked into the actual DLL that you're running. It implements an interface called iService Administration, and it establishes these characteristics. It says, this is the name of my service, this is the application, this is the proxy, this is the create page, so that if somebody wants to come, this is what I was calling new.aspx on the previous slides, okay? So this is the link to get to that one. So it's basically saying, I have a service. That's it. You inherit from 2 base classes. You can minimally make a default constructor, put type name in there, and override a couple of methods that say, basically, this is the name of my service, and this is where my new page is. There you go. You're good to go. Instances is a property that's going to point to the collection of the actual servers that are running this service. Okay, so that's coming momentarily. I just want you to know that this object, once it's established, has that property. So service instance is that on-off switch, right? If they go to services on server and say, I want this on here, then it shows up in the new drop-down of managed service applications. That is this class right here. So services on server, the on-off switch. It inherits from only one class, the SPIAS service instance. Notice how they use the same suffixes that I'm using, or I'm using the same suffixes that they're using, however you want to say it. This says started or stopped, right? So it's got a property that says whether it's running on a given server. Only one instance per server. Right? So you're not going to have lots of instances of these in a given server context. It defines the public interface that the clients are going to be able to consume. So this establishes, here are the methods that are callable. So this is kind of like the contract, right? It makes available the list of things that could be called. The service then is only functional if at least one service instance is turned on somewhere. If all you've done is deployed this WSP and there's a service for the farm and there's a service proxy, which I haven't talked about yet, for the farm, and that's it, no service instance, no services on server have ever been established, then you can't call it. Because this is the callable, this says, I can be called on this server. And it surfaces it to the application pool, what's it called, the application proxy pool, that this is the callable things. Think of this as WSDL. This is your WSDL document, right? They turn this on and then you say, on this server, these are the methods you can call. That's what it's going to happen, okay? And then this populates the new dropdown. I already talked about that, and it's called in sequence. It's a round robin. Unfortunately, they didn't make it least busy. Think about it. How many load balancers do you think Microsoft already has written? Why couldn't they have just given us a plethora of them to choose from? I don't know. They didn't. Not only that, but you must manually make a call to, you have to override the methods and manually make a call to the load balancer, even though there's only one, and that's the only one you can choose from, and it's the same code every single time. Unless you decide to plug in your own load balancer, you're always going to write the same code there. So it seems to me like instead of overriding those methods, they should have just implemented that code to call the default one, and we would only override those methods if we had our own custom one. But that's not what they did. So you always have to implement load balancing, even if you plan on just running it on one server. The load balancer has to be callable. So you always have to put the same code in all the time. It drives me nuts. Service application. So this is the third one on the server side, right? So we got service, service instance, and now service application. This is where the actual WCF service gets called, or the code gets implemented to do whatever the service would have done, right? This is the actual meat. Make a call into my actual service application. So it implements the service contract. So whatever the contract is with your WCF service, you're going to implement that. Say, here's my implementation of that contract. It's hosted by a service instance, right? This service instance is going to actually make an instance of the service application for you. If it doesn't exist, they'll go check. The service instance will go, hey, somebody's trying to make a call on this server. And they'll go, oh, gee, there's not one. They'll go make a service application for you. So if the server gets rebooted or something, service application is always created by the service instance. That's its job. Okay? Establishes the characteristics of the actual service application, like where is the SVC file? What are my endpoints? What can I pass out to somebody saying, hey, this is where you would make calls to? You know, these are the method calls that I am going to facilitate. It also talks about the manage and the properties page. So I talked about the create or the new page, right? This is the other two pages get established by this guy here. Let's see. It contains administrator settings and it can contain data. So you can say, in this one here, I want to go ahead and access my database, the database that was created for me. Remember, that's an optional thing. That optional thing would happen up in, I don't know if it's service or service instance. I think it might be when the service instance gets provisioned, it determines whether there's a database or not and goes out and makes the database or just says it exists. So I think the service instance is responsible for that. If the last service instance gets removed, turned off, then the database will go away. Right? They'll scratch that out. You get to call a provision and an unprovisioned method to determine how that database is being handled and what its schema looks like. Okay, service endpoints, and I need to talk about this just briefly. So what's a service endpoint? WCF has this concept that you can establish the service endpoints in a web.config file. How many people think it's a great idea to modify the SharePoint web.config? Good, no hands went up, right? You should only do that when you absolutely must. So here's what they did for service applications. They said, we're not going to put them there. Instead, we're going to put separate web.config and config.config and client.config files into a different place in the SharePoint root. So you don't have to stick this metadata about how a WCF surface is going to be surfaced into the SharePoint web.config for each web application. Instead, we're going to have one place in the SharePoint root for each web front end where we're going to dictate what that looks like. That file should be deployed with your WSP cab. That's not functionality. That's just deploying a web.config and a client.config file to the SharePoint root web services or web client. Okay, those two folders I talked about earlier. Oh, there they are right there. The web.config, and that second one should actually say client.config. Or, if you're not familiar with it, you can actually use an existing surface, surface an existing WCF surface by creating a WCF I can't say this right, by creating a WCF service inside of the ISAPI folder where instead of doing web config modifications to SharePoint, you use a service host factory in the SVC file to auto-generate MEX endpoints. So I know I said a lot of big words there, right? But just hear what I'm saying. If you want to surface a WCF if you want to surface a WCF service from the ISAPI folder, the _VTI bin, virtual directory, right, of a SharePoint web application, you can do that without modifying the web.config file by simply specifying a call out to a namespace and class name inside of one of SharePoint's DLLs that will auto-generate endpoints at runtime. The endpoints that it'll generate are MEX, the MEX endpoints, the metadata exchange. Metadata exchange endpoints is just one of the standards, like HTTP, HTTPS, we've got MEX. So if you don't want to have the WCF service delivered with your service application, you want it to already exist, so you can call it in other contexts. And then you want to just make that available to other farms or for whatever reason to be managed within a service application. You can use that same SharePoint WCF service from within your service application by allowing those auto-generated MEX endpoints. Therefore, you have no web.config in the web services, and you don't need to somehow modify the web application where it's being hosted's web.config either. So if you're confused by that, just look up how you create a custom WCF service in SharePoint 2010, and it's much improved over what we had in the previous releases. You gotta somehow manage all your other WCF stuff as well. The bindings, the authentication mechanisms, what I call the magic numbers. Have you ever looked at that web.config entry? There's lots and lots of magic numbers. Most of them are not necessary. You can actually glean them out and say, hey, just those are the defaults, so I don't care about those. Just give me the raw stuff that I must have in order to surface that endpoint. Okay, so I've covered the 3 server ones. Anybody, what are they? Service, service instance, service application. Hopefully you understand what those 3 things do, right? Now, that establishes that I can call my WCF service. But how am I going to make that happen? I'm going to need a client that calls somehow to a service proxy that's going to identify the service application proxy. And the service application proxy is then going to call the appropriate application, service application that's going to talk to the WCF service. Okay? I'm going to say it one more time. I actually drew the picture backwards from what I've been talking about. So I'm going to draw the picture one more time with my hands. The client is going to talk to, it's actually the application proxy group, which you have to set up and say, these are my application proxies for this web application, right? So you say, hey, service, SharePoint service context, what is my application proxy group? It's going to say, okay, well, here's your application proxies. So you say, well, I'm going to use this one to go get an instance of that application proxy to find out which specific service application I should call. Here's the load balancer, go get that one, right? So that the client can make a call through the service application proxy to the service application, finally to the WCF service. So it's a lot of chaining, right? In fact, the service proxy is really just establishing through the actual base class and the interface that these are the necessary things I need to do in order to be one of these things. My client's going to have to be able to talk to a service application proxy, which means the application proxy group is going to have to know that I exist. So I'm going to establish that I have one of these, right? And then it identifies the service applications that SharePoint can connect to. So it can say, hey, I'm connectable. Right? Some other farm can talk to me, right? If I don't say it, I can say no other farm can talk to me too, right? So I can turn off that publish connect capability from here. And then it has a class factory to generate service application proxies if we would need them, okay? Service application proxy then is the last class that we're going to talk about. This is on the client side, okay? And the service application proxy, again, it inherits from a base class. This time there's no interface unless you do optional stuff, right? This is the public face on the front end for the service application proxy group to make available the actual service applications that we have instances of. You know, I didn't actually say this, but I probably should have. The service application that's sitting over in central administration where we clicked on new and we made one on the server side, why would we have multiple service applications? Why would that be possible? Multiple web apps, okay, that's not quite what I'm looking for. There we go, that's what I'm looking for. One service application might have wait 3 minutes, right, and the other one might be wait 30 days. So they might have different characteristics. So I can have multiple service, it's uncommon, right, but I could have multiple service applications because they have different configuration And since the configuration screens are surfaced in central administration, you can have multiple. It's really sad that they called the service application because they really feel like instances of a service application. You want to call it a service application instance. But there's a service instance that you don't want to call it that because the word instance is in the sort of parent class. But you can think of it like the service application is the actual instance of the thing, and then the service application proxy is the thing that's surfacing it to the client, making that available. So there's a one-to-one between service application and service application proxy. It's unfortunate that this name is called a proxy too because it doesn't really do what the proxy did back in the COM+ days. Back in the COM+ days, the proxy actually sat on the client. In this case, it actually sits on the server and the client just gets a copy of it. So the way that the client gets a copy of the service application proxy is it asks the service context, where's my service application proxy? And it says, oh, it's this one over here. And so then it literally takes the default one and gives them a copy of that object. So now the client has that object, then they can make calls. So the service application proxy actually includes the hardest code that you're going to have to implement. In my opinion, this is the code that I most dread. It's because it uses Lambda expressions to make calls into a channel factory such that when you make a call through the service application proxy, you're channeling the actual contract that the service application has established through the WSDL in the service instance. Terrible, right? Sounds just absolutely horrific. So you need an example. You need to see how this is done. It's not hard syntactically to go, oh, I see what's happening. It's just, who made up this thing? It's like, man, this is complicated. I don't even know sure what's happening here. And then you have to have some little helper methods that actually do the channel factory, where 90% of the code is identical to the previous thing, except for the method name and the parameters. So the method name and the parameters are different, but you have to write a separate code, a channel factory for every method to say, oh, well, the service application proxy is going to get to the service application exposed by the service instance, right, by calling into this channel factory through this Lambda expression. Guess what? If you're the developer, I highly recommend you create a simple client class that establishes simple method calls that abstract the complex channel factory code so that nobody has to go and write that in every single client. Instead, every single client is just calling into this one method which calls into the channel factory stuff that you wrote once. So you stick that out for a separate class and make that channel factory, that horrific channel factory stuff, so that you're only writing that and invoking it one time. But effectively, all it's really doing is it's saying, hey, look, client, here's how you can get a hold of the actual service application, which is going to actually talk to the WCF service. Right? So hopefully these terms and the concept of how they fit together is coming into a little bit clearer, coming into view. So you're probably going to need some service application pages. Certainly your central administrators, unless you're building one of these for them when they deploy this solution, right, they're going to want a new button. They're going to be able to say new and make one of these and create a service application and its associated service application proxy. Right? They're going to expect that that new button just works, which means you're probably going to need a new.aspx page. You may need a manage page and you may need a properties page. I'm going back to those optional things that you may want to do. The new page should establish the application pool because it's actually going to go make an actual IIS website, right? Here's the really baffling thing. Guess where it hosts your WCF service that's auto-generated and made available on each server where a service instance is turned on. Guess where it puts it? It puts it in IIS, in an IIS website called SharePoint Web Services, which is not a web application, by the way. It's just an IIS website. So they literally are auto-generating like applications underneath of an IIS website for you called SharePoint Web Sites. The SharePoint Web Sites is where all of their service applications are generated. I haven't figured it out yet. It always makes my application a GUID. Somehow they got one of theirs to be a non-GUID. I haven't gone and looked in Reflector yet, but somehow they made it a non-GUID. All the rest of their service applications are GUIDs, just like mine. So it's kind of hard. You have to click in to see the actual contents of the application under SharePoint Web Services. If you've done FBA, you already know about this location because you have to modify a web config that's there, and there is no web config modification to it because it's not a web application. It's just an IIS website. So you literally have to write imperative code to go get an IIS website, get a web config out of one of those folders, and use standard XML to manipulate it. Right? Because there's no SharePointiness about it. It's just this weirdo sort of website sitting off to the side where they auto-generate web applications applications, which is your WCF service. Okay? Move on, consumers. So once we've built all of this whole Taj Mahal, and we've got all of these pages, and we've got all this capability, then we have to write a service. I mean, we have to write a client. So you're going to have to write a web part. You're going to have to write some kind of a page. Maybe you're going to write a WCF application over here, right, that's going to call into it, or Silverlight function on your ASP.NET website or whatever, something that needs to consume this. I would highly recommend that you create a simple class that you give to them that says, call these methods, and we'll do all the heavy lifting to get an instance of each of those methods and call it for you so that they don't have to understand the whole, how do I get the SharePoint service context, how do I then get the application proxy group to get the actual service application proxy that I'm going to use to do the channel factory stuff to talk to the service application, right? All of that code is in a little helper method, a little helper class that they just use in whenever they're consuming your service. That's why I say provide others with a service consumer client is what I would call it, service consumer client. So how do you make your first WCF, or how do you make your first service application? How do you get in here and actually make one of these? First, go download the sample. That will help a lot. Almost every sample that I found on the internet thus far doesn't work. You go through the whole process and you try to run it and it says, sorry, doesn't work. So I want to check out mine before you download mine so that it does work, okay? So I'm going to try to do what you would have to do and try to maybe give some instructions and stuff like that. First thing you're going to do is create your service, right? Host it in IIS and say, hey, I have a service. Or make it available so that, do what I just said here. Right? Create the service, host it in IIS, and make sure it works. So if your service doesn't work, you're not going to be trying to debug that through the service application calls. That would be horrible. Right? Use your WCF client test, make sure that that WCF service works. Once you know that that service works, then you can host it in a service application. Okay? Then go make your 5 classes, make them all public, give them a default constructor, make the type name be a nice display name. Implement the class, the base class and the method and the interfaces that are absolutely necessary. Make sure that you're adding a GUID to the top of every one of your classes so that they can be serialized and can be rehydrated. Go ahead and in your feature receiver for your overall feature, your farm feature, go ahead and, do I have this farm feature? I think this is farm feature. It might be a web application feature, but I don't think so. If it is, it's a web application feature for central administration. So central administration would be the web application I'm targeting. But I think it's a farm feature. Oh, right there, it says farm feature. So you make a farm feature, right, and you put the feature receiver. I should just read the slide, right? You make I'm trying to remember it, right? I did it. Farm feature with a feature receiver in it, and in the feature receiver, you create the service, you create the service instance, and you create the service proxy. I recommend that you make a service instance, one for each server. So you iterate through all your servers, and you make one service instance for each one. That's different than what I see everybody else do, but I just think everybody else is testing it on their dev box where they've got how many web front ends? 1. So how many servers do they have? 1, right? So, hey, it works. Works on my box. Well, I don't think that's going to work. I think you're going to have the middle one there where service instances, you get 1 for each. That way, now when I go in, I can click on new, and I can create one of these, and I can say services on server, true or false, and I can say which server I want to have it on. So I can turn it on and off. Then go make your proxy, update your proxy groups so that you're saying, hey, this web application has my service application in it, right, so that it's in the proxy group so your client can consume it. Use PowerShell to auto-create stuff. That's that post-deployment thing I was telling you about. So you don't have to go in and click through the actual administrative interface in central administration to make it happen. If you choose not to do the next to the last step there, you're going to need a new.aspx page that does all that stuff for you. Yeah? My little PowerShell script just assumes that I'm going to use the same application pool that the security token service uses. Sorry, Paul. The security token service always is available in every single SharePoint instance. So as a dev, I just say, hey, that application pool will always be there. So I'm going to just use the same one that they're using, and it's going to have uber permissions of whatever its application pool identity is going to have, everything I need. Or central administration, one of those 2 application pools. Use one of those in your PowerShell script so that you can auto-generate this thing, and you don't have to have a new page yet, you don't have to have a PowerShell script yet, you don't have to have a farm configuration wizard working yet, you don't have to have all the rest of those pieces in place. You don't have to have a properties page. You don't have to have a manage page. You don't have to, all of those optional things I talked about earlier in the deck, you don't have to have those yet. You just have a working service application. Then you create a consumer, probably an application page, because that's the easiest one. Make an application page and make calls into your service application. Go get an instance of service. Go get an instance of the SP context, service context. Ask it what the service proxy groups are and get your service proxy group. Then get your service application proxy. So you have an instance of that on the client. It'll be a copy of the default one, right? Then make a call through the channel factory to the actual service application, right, which has its WSDL from the service instance, and it will make the call to the WCF service. Returns that all back through the whole channel, gets back to the original calling, and you display hello world. Once you have all of those pieces put together, now you can build whatever you want. You want a resume cruncher, you want a who's online, you want to have the most amazing, commercial software application that was ever written, you can do it. And it will be manageable by the central administrator to say it's going to run on these servers, load balanced, right? And I can have a backup and restore story so that the databases that are created automatically by that service application will automatically be accounted for by SharePoint's backup and restore, right? And I'll have all of the capabilities of properties and a manage page, and I'll have which administrators are allowed to do stuff with this thing, and I've got custom properties if the person implemented it, and I can have custom timer jobs that are running against this thing, et cetera, et cetera, et cetera. All of those optional things that I talked about are then available. I think that's it, right? So the idea is that if you create the basic hello world service application, I do get server time. So mine is just get server time. Because if I can get the server time through a WCF service way over here, from the client way over here, through that entire chain of classes, then when you're ready, you can just change get server time to whatever method you want, update your client calls, update your actual WSDL, implement the actual methods, and you've got your methods, and it runs through the same stack. Yeah? So the basic service application, get server time, that's the one I'm going to try to put up on the Mindsharp.com website. Mindsharp.com, free resources. Find this deck, and hopefully I can get the code up there in the next couple of days. Sound good? Questions? General questions, just real quick before I finish up. Anybody got something I missed? Yeah, over here. Yeah, you're right, in the middle. Just say it really loud. Yeah, very good. So she says, does the WCF surface, I keep saying service and surface, does the WCF service that we're going to be auto provisioning happen during the deployment of the WSP cab, or during when I turn on service instance, when I turn the on-off lever? It depends on what you want to do. If you want the service already to exist, and your service application is just presenting an existing service, then I would make a separate WSP to deploy the service out into SharePoint, or just into however you want to deploy it, so that that service already exists, and all your service application is doing is making it available. However, the model that they give us bakes it in. So when you say, I want to services on server, I want to start the service, it literally at that moment goes to that server and provisions a new IaaS website application, which is your WCF service, which uses the web services and the web client config files as its endpoints. Right? So the two config files are deployed with your WSP, but the actual service itself is created in IaaS when it says started. When you say start, that's when that IaaS website goes on. When you say stop, it goes off, unless there's two pieces. You have to turn it on, and you have to make a new one, right? If you make a new one, and it's not on yet, nothing happens until you turn it on. So those two things both you have to make a new one, and you have to turn it on. Then it makes the SharePoint Web Services application, which is your WCF service. That's how it gets provisioned. Does that help? Because that's a complicated part of this whole process. That happens during a method called provision. The word provision, just so you know, the verb provision means take it from the file system and actually put it into the SharePoint content database, right? Make it available in SharePoint, provision it, right? So in this case, provisioning would include creating that IaaS website. Excellent question. I think I'm out of time. If you've got questions, I'll hang around here. Afterwards, I'll probably hang out at that door back there, but have a good afternoon. Hopefully this is useful. Oh, don't forget to do your what is this thing called? Your evals. You can use this super duper Microsoft tag, point your phone at it, go click, and it'll take you right to the page where you can fill out your eval. It's requisite service application. It's a 400 level thing, so all fives is mandatory. Right?
Just a quick question about authentication. We at my company have web services, and we authenticate using Kerberos and Active Directory.
Excellent.
In SharePoint, in the scenario you just painted here, is that possible?
It's perfect.
Yeah.
In fact, that's the ideal.
Is it easy to turn on? Is it like a switch?
Oh, you bet. Yeah, yeah, that's ideal.
So it's still the same structures that we have now in II.
Exactly right. In fact, what happens is that because you're hosting the service application in SharePoint, anything SharePoint can do from an authentication perspective is part of your service application.
Right. So the client in your structure here can be web or
anything, right?
Client,
Yeah,
anything.
it can be a traditional Windows application sitting on a client somewhere.
Mobile.
Yeah, mobile. I haven't tried mobile, but yeah, it should be.